I'm going to teach you how to balance equations. So I'm going to do a few examples on paper, but before that, I'm going to show you this simulation. So here we have a chemical reaction. We can see there is nitrogen reacting with hydrogen to make this compound here, which we call ammonia. So let's add one of every molecule and see what happens. Well, we can see at the top that it counts up the number of each atom, and we can see in this white box how many atoms there are. So immediately we can see that the number of atoms of each of them are not equal. Before we have 2 nitrogen, after we only have 1. Before we have 2 hydrogen, after we have 3. So that's not very good. So how can we balance it? Well, let's add a second molecule over here and see what happens. Well, now we've got 2 nitrogen, 6 hydrogen. So the nitrogens are balanced, that's great. But what about the hydrogens? They're not balanced. But maybe if we add some more hydrogen to the other side, we can make it balanced. Well, that's a bit closer. What about if we have 3? Great, now we have the same number each side. Now you'll notice the number is a big number before the molecule. And that's because we're allowed to add other molecules, but we cannot change the chemical formula. So when I change this number, you can see what happens. It adds more of the molecule. We're just adding extra copies of it. That's what that number means. So let's do a second one now. Let's look at this reaction here. So we've got water is being split up into hydrogen and oxygen. So let's add one of each and see what it looks like. Well, we can see that we've got 2 hydrogen before and 2 hydrogen after, but we've only got 1 oxygen before and 2 oxygen after. So that's not balanced. So let's add another one to the left-hand side. Now you can see the oxygen, there are 2 before and 2 after. But what about the hydrogen? We've got 4 before and only 2 after. So that's not good enough. We need to balance it. So what we can do is add some more hydrogen to the product side. And look, now we see when we double the number of molecules, we've got 2 times 2 is 4, and that balances. So what does this look like on paper when we're actually doing it in our book? So here we've got a reaction. This is sodium plus bromine goes to sodium bromide. So what I'm going to do for my first step, I'm just going to put a line down the middle just so I can separate the reactants from the products. I'm then going to count up, just like we were doing with that simulation, how many of each atom I've got. So I've got on the left-hand side 1 sodium, and I've got 2 bromine. On the right-hand side, I've got 1 sodium, and I've got 1 bromine. So what have we got? The sodium is the same, but the bromine is not the same. So what I can do, I can double the number of bromine that I have. So I'm going to times it by 2, so I've now got 2 bromine. Now, because I've times it by 2, what I'm doing is basically adding another whole one of these molecules, right? So I've got 2 bromine, but what do I also have? I also have 2 sodium. So I've also times this by 2, okay? So now when we look, we've got 2 bromine before, we've got 2 bromine after. We've got 2 sodium after, but how many sodium did we start with? Only 1. So what do we need to do? We need to make sure we have 2 sodium, so it's the same before and after. So we make sure we've got 2 sodium. Now we've got the same before and after, it's balanced. Let's look at a second example. Here we've got aluminium and oxygen are forming aluminium oxide. So the first step, I put a line down the middle to separate the reactants and products. Then I'm going to list all of my atoms. So we've got before, we've got 1 aluminium, we've got 2 oxygen. Afterwards, we've got 2 aluminium, because there's a 2 there, and 6 oxygen. So how can we get from 1 aluminium to 2 aluminiums? Well, obviously, we can times that by 2 to get 2, which means I'm going to times that by 2. What about oxygen? How do I get from 2 to 6? Well, I'm going to times that by 3 to get 6, which means I have to put a 3 here. So now we can see we've got 2 aluminium before, 2 aluminium after, 6 oxygen before, and 6 oxygen afterwards. This is now balanced. Let's look at another example. So here we've got boron plus hydrogen makes boron hydride. So first step, put the line down. Second step, list how many of each element we have before and after. So 1, 2, 1, 3. Now you'll notice here, there's no easy way to get from 2 to 3. We're not allowed to do, times by 1.5. So we've got to make whole numbers. So what we can do is find the lowest common multiple. So we can times this by 3 to get 6, and this by 2 also to get 6, which means we've times the hydrogen by 3, and we've times this side by 2. Now, because I've times this side by 2, what have I also changed? I've actually also changed the number of boron that I've got. I've also times this by 2. So now I've got to do something to the other side. I've got to make sure the boron over here is the same. So I also times it by 2 to get 2. Times it by 2. Now let's check. 2 boron, 2 boron. 3 times 2 is 6. 2 times 3 is 6. It's balanced. Okay, we'll do one more example. Pause the video now and try this. Okay, see if you did exactly the same as me. First step, draw the line. Second step, list the number of each atom. 1 vanadium, 2 oxygen, 2 vanadium, 5 oxygen. Realize that there's no easy way to get from 2 to 5. So we need to find the lowest common multiple, which in this case is 10. So 2 times 5 equals 10. 5 times 2 equals 10. So we times it by 2. We times it by 5. Now we've also times the vanadium by 2. 2 times 2 equals 4. So we need to have 4 over the other side. 1 times, obviously, 4 equals 4. So we put a 4 here, and now it is balanced. Got some more questions for you to work through. So pause the video now and try all of these questions. Let's see if you got the answers right. Here are the answers. If you managed to get the last one right, you're doing pretty well because this was challenging. So well done.